Welcome to the deep dive. Today, we're tackling something really fundamental as AI evolves, how these systems communicate about communication.
Yeah, what's being called meta-artificial communication.
Exactly.
We've distilled a lot of research into a report we're calling meta-artificial communication,
Mhm.
in-depth analysis. And it really points to this crucial layer beyond just, the data exchange between AIs.
Right.
We're talking about the signals that govern how that exchange happens, sort of the hidden rules of engagement.
Which is becoming so important for anyone trying to, well, understand where AI is headed. Because as these systems get more intricate, more autonomous, collaborative, just knowing what they do isn't enough anymore.
You got it. We need to understand the coordination underneath it all, the how and the why.
Mm.
So our goal in this deep dive is really to unpack this emerging idea. We'll look at its different sides, from AI talking to AI to how AI might explain itself to us humans. Ultimately, we want to shed light on why this meta-level stuff is so vital for the future of AI and, well, our place in that future.
All right, let's unpack this. Maybe start with something we all do every day. Human conversation.
Good idea.
Like, think about when the meaning of what someone says goes way beyond the actual words. The communication guru, Paul Watzlawick,
Oh, yeah, Watzlawick.
he pointed out that every message has, like, a content part, the literal info, and a relationship part, how you're supposed to take that info.
Right.
And that relationship part, that's basically meta communication.
Precisely. It's the context we provide about the communication itself. Think of your tone of voice signaling sarcasm.
Or when you say, hey, don't take this the wrong way, but
Exactly. It's communication about the communication. We're constantly shaping how we understand and respond to each other. We use it to clarify what we mean, set ground rules, navigate relationships.
okay, so if we humans are constantly doing this meta communication dance, what does it actually look like when AIs do it? Let's dive into that first dimension. AI to AI med communication. Why do they even need it?
Well, it becomes absolutely critical when you have multiple AI agents trying to work together. Think about what you might call the communication conundrum in these multi-agent systems.
Tantrum. How so?
You've got this collection of AI entities, right?
Yeah.
And they might be built on totally different foundations, different architectures, different LLMs, the brains, basically different skills.
So they're all speaking different internal languages, essentially.
Pretty much. They're inherently a mixed bag. It's not like they all just automatically understand each other.
Right. So how do they bridge those gaps to actually collaborate effectively?
That's exactly where meta communication comes in. We're looking at some really fundamental technical hurdles that, well, make these meta communicative solutions necessary.
Like what?
Okay, first up is semantic interoperability. This means going beyond just the structure of their messages to make sure they're actually sharing meaning.
Getting on the same page, definition-wise.
Exactly. This might involve them agreeing on, say, shared ontologies. Think of those as common dictionaries and rulebooks for a specific area. Or even negotiating the meaning of terms dynamically as they interact.
Wait, negotiating meaning on the fly? That sounds incredibly complex.
It is, and that ties into another vital area, dynamic negotiation. See, in the real world, things change constantly.
Uh-huh.
So communication rules set up in advance might suddenly not work anymore. Agents need to be able to adapt, to dynamically agree on how they'll interact, or even which communication protocols they're going to use.
Protocols about protocols.
That's the idea of meta-protocols, yeah? Protocols designed specifically to negotiate other protocols.
Wow, okay, meta all the way down.
Yeah.
So beyond understanding each other and agreeing how to talk, what else do they need to communicate about at this meta level?
Well, security and authentication are huge, especially when you have agents from different systems, maybe even different companies, talking to each other.
You gotta know who you're talking to and that it's secure.
Definitely. They need ways to verify identities, protect the messages. And then there's the sheer challenge of scalability.
Meaning?
As you add more and more agents to a system, you have to make sure the communication itself doesn't become this massive bottleneck, just slowing everything down.
Makes perfect sense. Now, this whole idea of AI communication standards, it's not totally new, right? People have tried this before.
Absolutely. Let's do a quick history detour. Agent Communication Languages, or ACLs. Early ones like KQML and FIPA ACL popped up back in the 90s.
HIPAA ACL, I think I've heard of that.
Right. They're based on this cool idea from speech act theory. The idea that messages aren't just passive info, they're actions.
Like a request is an action or an offer.
Exactly. A message could be a request, an offer, a promise, and it implies an expected response.
So what did one of those FIPA ACL messages actually contain?
Oh, it was quite structured. You had the performative, That's the type of action like request or inform.
Hmm.
Then sender or receiver, the actual content, the language used for the content, the ontology.
Ontology, again, the dictionary.
Right, defining the terms. Plus the specific interaction protocol being followed, and a conversation ID to keep track of the back and forth.
That's a lot packed into one message. So what were the key pieces of these early ACL setups?
Typically, they defined a specific language, like FIPA ACL with its list of actions, then a syntax for how to format the messages, and finally, various interaction protocols sort of predefined scripts for common tasks, like asking for info or negotiating something.
Okay, seems pretty comprehensive. So why didn't they just solve the whole AI communication problem back then?
Well, they hit some roadblocks. For one, the formal rules about what the messages meant, especially in FIPA ACL, got really complicated. They often relied on assumptions about the agent's internal mental state, which is hard to actually check from the outside.
Yeah, how do you know what an AI is thinking?
Exactly. And they also turned out to be pretty complex to implement fully. So while FIPA standards did get used, the field kept looking for, more flexible ways.
Which brings us more or less up to date. What are some of the newer protocols trying to do differently now?
Yeah, now we're seeing protocols like Agora, A2A, MCP, and these are really built for the current AI world, especially with LLMs everywhere, and the need for systems that can actually scale up.
Okay, let's take Agora first. What's its main idea?
Agora is designed as a meta protocol, and it directly tackles what some call the agent communication trilemma.
The trilemma sounds ominous.
Huh. Well, it's this challenge of trying to get three things at once. Versatility, handling lots of different kinds of messages and interactions. Efficiency, keeping the computational cost low, especially if you're using power-hungry LLMs. And portability, making it reasonably easy to use across different kinds of AI agents.
Okay, versatility, efficiency, portability. Sounds like you usually have to trade one off against the others. How does Agora try to manage that?
It uses this hierarchical and adaptive approach. For common, well-defined stuff, it uses efficient standard routines, almost like calling an API, quick and cheap. For rarer or totally new interactions, it can fall back on the flexibility of natural language, even though that costs more compute power. And for situations in between, it can even use LLMs to dynamically generate specific communication routines just for that situation.
Clever. And I saw protocol documents mentioned. What are those?
Ah, yes, PDs, protocol documents. They're key. They're these self-contained descriptions of communication protocols, but they're not tied to any specific way of implementing them.
So agents can understand the protocol without needing, say, an LLM every single time?
Exactly. It reduces that dependency. Agora also focuses on being compatible with older systems. It pushes for decentralization, and early results suggest it can really cut down communication costs and help with scaling up.
So Agora's trick is using the right tool for the job efficiency for routine, flexibility for new stuff.
Precisely. It's a smart balancing act for these big multi-agent systems.
Okay, that's Agora. Now, the Agent Network Protocol Framework, ANPF, sounds quite layered. What's its approach?
It is structured. It proposes three layers. At the bottom, you've got identity and encrypted communication, basically security, often using decentralized IDs. Above that, the application protocol layer. This is about what agents can do and the specific protocols they use for certain tasks.
And the top layer.
That's the meta protocol layer, crucial for our discussion. This is where the agents actually negotiate which communication protocols they're going to use for a particular chat.
Ah, so they talk about how they're going to talk?
You got it. And this negotiation can happen using natural language, like agents just describe what they need and suggest protocols. The framework even imagines AI potentially generating the actual code for the protocol they agree on.
Wow. Okay, so that's meta communication focused squarely on setting the rules of engagement for the communication itself. What about A2A? That's from Google, right?
Correct. A2A, agent to agent. It's an open protocol specifically for direct communication and coordination between autonomous AI agents. The main goal is seamless interaction, no matter what underlying system or platform the agents run on.
Like a universal translator for AI agents.
That's a good way to think about it. A2A's vision is this common agent web. It highlights how important standardized interfaces are becoming for AI collaboration, moving towards a whole ecosystem, not just isolated apps.
So what's A2A trying to achieve specifically?
Its primary focus is enabling multi-agent workflows, letting agents hand off tasks to each other, work together on problems.
How does it do that?
Key features include a way for agents to find each other based on their advertised skills using public cards. It also standardizes how they exchange task info, inputs, instructions, results, status updates, that sort of thing.
Okay.
It supports different ways of communicating, has security built in, and it's even designed to deal with opaque agents ones, where you can't see their internal logic.
Sounds like they really are aiming for that lingua franca for the agent web.
That's exactly the ambition. Google sees A2A as potentially the foundational language for this emerging world of connected AI agents.
Okay, one more modern protocol, MCP from Anthropic. How is that one different?
MCP, or Model Context Protocol, tackles a slightly different angle. It's less about agent-to-agent talk and more about how a single LLM or AI assistant can effectively use external context and tools.
Ah, so connecting one AI to the outside world.
Precisely. It standardizes how info from things like APIs, databases, or files gets fed into the model's context window, and how the model's output can then trigger actions in those external systems.
So it's about giving an individual agent arms and legs, metaphorically, access to data and actions.
You could put it that way. It sets up secure links between the AI model and the resources it needs for tasks that involve real-world data or taking action outside itself. You have these components like MCP hosts, servers, clients, tools, data sources, all interacting via this defined protocol.
Okay, so A2A is more like horizontal communication, agent to agent. MCP is more vertical, agent to environment or agent to tools.
That's a great summary.
They sound like they could actually complement each other quite well.
Absolutely. That's a key point. While they both boost AI capabilities, A2A is for collaboration between agents, while MCP focuses on an agent's interaction with its surroundings. You could easily see an agent using MCP to get some data, and then using A2A to work with another agent based on that data.
This is, wow, a lot to digest, but it really drives home how essential these interaction protocols are becoming as AI gets more complex. And this idea of meta protocols seems especially powerful.
It really is. The ability for agents to dynamically negotiate other protocols gives you incredible flexibility and adaptability, especially when you have diverse agents with different skills working together.
Right.
They can use natural language to figure out what's needed, propose protocols, maybe even have AI generate the code for it. And negotiation protocols aren't just for setting up communication. They're also vital for reaching agreements and sorting out conflicts in multi-agent systems.
Okay, so protocols handle the language and the rules, but what about the higher level structures for actually building and managing these systems in the real world?
Good question. That's where agentic frameworks come into the picture. Think of them as like the architectural blueprints for building these collaborative AI systems.
So they provide the overall structure.
Exactly. Structure, ways to orchestrate how agents interact, and they often build in or make it easy to use the communication protocols we've been talking about.
Can you give us a couple of examples? What do these frameworks look like?
Sure. There's LangGraph from the LangChain world. It uses graphs to define how agents work together, and it can even handle cycles for more complex back and forth processes.
Okay.
Then there's Crew AI. It's specifically designed for teams of autonomous agents that play different roles, collaborating like a crew on complex tasks. Big emphasis on collaborative intelligence there.
Crew, I like that.
There's Swarm, reportedly from OpenAI, which seems to take a more minimalist approach, just agents and handoffs to pass control. And then you have older, more established ones like JDE. It's Java-based, follows the older FIPA standards, and you still see it used in things like robotics and logistics.
So the frameworks are the scaffolding, and the protocols are the detailed instructions for how the bits inside talk to each other.
That's a really good analogy. And you can see how these frameworks and protocols are kind of evolving together, right? You really need both to build and deploy practical multi-agent systems effectively.
Now, we focused a lot on AI to AI talk, but I also saw meta-level control mentioned in our notes. What's that about? Sounds deeper.
It is quite deep. Meta-level control refers to an agent's internal capability to reason about and manage its own thinking processes.
Like an AI thinking about how it's thinking.
Kind of, yeah.
Yeah.
It's especially important when an agent has limited resources, time, computing power, whatever. It has to make decisions like, should I spend more time thinking about this?
Yeah.
How much effort should I put into planning? Which strategy is best? When and how should I coordinate with others?
So it's about optimizing its own internal decision-making for efficiency.
Exactly, for efficiency and effectiveness. And when you have multiple agents working together, coordinating these meta-level decisions becomes really crucial.
Why is that?
Well, imagine one agent is taking ages to plan its next move, while another is just waiting for a quick answer. That gums up the works for everyone.
Right.
So agents might even engage in what's called meta-level message passing. They actually exchange information about their internal control state, things like how certain they are or how long they expect a task to take.
That is a very intricate level of coordination. Our notes mention some early research here.
Yes, pioneers like Anita Raja and Victor Lesser did really important work on meta-level reasoning and control architectures in multi-agent systems. For example, they worked on a project called NetRads.
NetRads.
Yeah, coordinating a network of weather radars. The agents would communicate about their control states to dynamically adjust their scanning patterns and get the best overall data. It's like a deeper layer of meta-communication focused on optimizing the thinking process itself within a team.
Okay, we've covered a ton on how AIs talk to each other, but you mentioned the agent communication trilemma earlier. Can we unpack that core challenge a bit more?
Sure. The agent communication trilemma really gets at the fundamental trade-offs you face when designing these AI to AI communication systems. You've got three things you want: versatility, handling all sorts of messages and styles; efficiency, communicating fast with low computational cost; and portability, making it easy to implement across different types of AI agents.
And the trilemma part is that you can't easily have all three at maximum level.
Exactly. You usually have to compromise. For instance, using plain English gives you massive versatility, right? But it can be computationally expensive and maybe not the most efficient way for two machines to swap structured data.
Compared to, say, a very specific binary code.
Right. A highly efficient, specialized binary protocol might be super fast, but it lacks flexibility for complex or new situations, and it could be a pain to adapt to different agents.
Which brings us back to protocols like Agora trying to find that sweet spot.
Precisely. Agora's hybrid strategy, standard routines, natural language, LLM-generated routines, those protocol documents, it's all an attempt to navigate this trilemma, to find a workable balance.
But it's still an ongoing challenge.
Oh, definitely. It's a very active research area. There's lots of debate on the best ways to handle these trade-offs. It's pretty unlikely we'll find one single, perfect communication method that works for everything.
Okay, that gives us a really solid picture of the AI to AI side. Let's switch gears now to that second critical dimension. Human AI metacommunication. This feels like it's all about tackling that classic AI black box problem, right?
That's exactly right.
Yeah.
As AI systems get more powerful, their decision-making often gets more opaque.
Mm-hmm.
Harder for us humans to see how they reached a conclusion.
Which makes it hard to trust them or work with them effectively.
Exactly. That lack of transparency is a major barrier to building trust and fostering real collaboration between people and AI.
And this is where explainable AI XAI comes in.
Yes. XAI is the whole field dedicated to making AI systems more understandable to us. The main goals are, well, building user trust, helping us spot and fix errors, providing a basis for accountability when things go wrong, and honestly just satisfying our basic human need to understand the tools we rely on.
And you said earlier that XAI itself is a kind of meta communication. How does that work?
Well, think about it. When an AI gives you an explanation, it's not just giving you the output. It's communicating about its internal state, or its reasoning process, or the key factors behind its decision.
Ah, it's explaining how it got the answer.
Precisely. So designing good XAI is fundamentally about designing good human-AI metacommunication. It's about how the AI talks about its own process.
So what are some of the actual ways AI systems can do this? Explaining what mechanisms are there?
There are quite a few approaches being tried out. One is just explicit process communication. The AI basically outlines the steps it's taking or points out dependencies.
Like narrating its thought process?
Sort of. Another is using workflow visualizations, sometimes even with little placeholders, to show ongoing processes, giving you a visual map of what's happening. Think of those as like placebo pipes.
Placebo pipes.
Yeah, visual cues that show something's happening, even if you don't see the nitty-gritty details. It gives a sense of progress, like a loading bar.
Ah, okay, like a loading bar. That makes sense. It tells you it's working, even if you don't know exactly what calculations are running.
Exactly. Then there's the idea of revealing the journey, showing the reasoning path the AI took, the evidence it looked at, not just the final answer. Helps you understand the basis for the conclusion.
Okay.
Adaptive interfaces with feedback loops are also really important. They let the AI signal its understanding or intent and let the user provide corrections.
Like a dialogue.
Yeah, a bit. That cockpit information manager example in the RPA program is a great case. Pilots could see the AI's guess about the mission context and correct it directly.
That seems really useful.
We're also seeing research into more formal interaction protocols, using dialogue systems, argumentation theory to create personalized explanations that really fit the user's needs. And finally, things like input process transparency interfaces. They let you actually inspect the data the AI used and see how it affected the outcome, like in some recruitment tools.
Okay, those all sound like largely technical ways to crack open the black box. But our report also mentioned perspectives from sociology and systems theory, Lumen Esposito. That sounds like a different angle altogether.
It really is. These perspectives stress that communication isn't just about sending information from point A to point B. It's fundamentally about co-creating meaning between the parties involved.
Meaning it happens in the receiver's head.
Right. Understanding doesn't just get transferred. It's constructed by the receiver based on their own knowledge and context. And Elena Esposito, building on Nicholas Luhmann's ideas, makes this really crucial point. Effective explainability doesn't necessarily mean total transparency of every single internal mechanism of the AI.
Wait, explainability isn't the same as transparency. How so?
Think about how you explain something complex to another person. You don't usually try to describe every neuron firing in your brain, right?
No, definitely not.
Instead, you rephrase, you structure the information, you use analogies, you tailor it in a way you think will help them understand it from their point of view.
Okay.
Esposito argues XAI should focus on developing these effective communicative strategies, giving users the right kind of extra information to make sense of the AI's actions, rather than just trying to dump all the internal technical details on them.
So it's less about technical disclosure, more about communication that actually leads to understanding.
Exactly. Because how effective an explanation is really depends on the user's background, what they're trying to achieve, the specific situation. A generic one-size-fits-all explanation probably won't help everyone.
Right.
So this view really shifts the focus of XAI. It becomes a communication design problem. How do we design interactions that successfully get the relevant information across, leading to both understanding and trust?
That makes me wonder about the design principles then. What actually makes for effective human-AI metacommunication in practice?
Well, several things are key. Understandability and robustness, definitely. When an AI clearly communicates its process, you can anticipate its behavior better, spot errors.
Makes it more predictable.
Yes, and more auditable too. Then there's user acceptance and even etiquette. Systems that do this process talk offer feedback channels. They tend to be seen as more cooperative, more trustworthy.
Like that cockpit example again.
Exactly. The RPA Cockpit Information Manager really showed that. And the flip side is true too. Lack of metacommunication can just lead to frustration and distrust.
And what about bigger issues like fairness or building trust?
Transparency is huge there. Transparency about the data used to train the AI, about its reasoning that directly impacts whether people see the system as fair, especially in sensitive areas like hiring. And trust itself. Remember, it has those two sides. Cognitive trust. The rational assessment, is this thing reliable? Does it know its stuff? And effective trust, more of an emotional feeling of confidence.
Right, head versus gut feeling.
Kind of. Now, metacommunication through XAI and transparency mostly builds that cognitive trust. It makes the AI more understandable, more predictable.
Okay.
It also gives users more power, a sense of agency and control. You feel like you're collaborating, not just dealing with an opaque box that might or might not be doing what you want. It moves beyond that illusion of agency you sometimes get.
This clearly has implications everywhere. Our report listed a whole bunch of different application areas for meta-artificial communication. Maybe we can touch on a few to see how it plays out.
Yeah, absolutely.
Mhm.
Take software engineering, AI that can explain its code suggestions or debugging steps. That could seriously improve quality, speed things up, even help with prompt engineering for LLMs.
And maybe even help human teams communicate better, too.
Interestingly, yeah, the principles of clear process talk could definitely apply there.
And in human-computer interaction, HCI, it feels like metacommunication could make interacting with AI feel much more natural.
Totally. Think about chatbots or smart speakers now.
Yeah.
They often feel a bit clunky, right? Because they lack that ability to talk about the conversation.
Yeah, they just follow the script.
Adding metacommunication could make it feel less like dealing with a rigid processor and more like working with an intelligent partner. It links back to those adaptive interfaces that report their understanding. And fascinatingly, it works the other way too. AI is being used to analyze human metacommunication, like reading nonverbal cues.
Whoa. Okay, and we talked a lot about multi-agent systems earlier. How does metacommunication help them in the real world?
Oh, it's fundamental. Absolutely essential for coordinating complex jobs across multiple AIs. Think robots in a factory coordinating moves.
Or AI assistants booking meetings for you.
Exactly. Negotiating schedules or services.
No.
Simulating business workflows with different AI departments. Teams of specialized AIs solving tricky problems together.
Like the crew AI idea.
Right. Or even real-time resource coordination, like that NetRads example, coordinating weather sensors. They
Mhm.
need to communicate about their status, their plans. We're also seeing these decentralized frameworks pop up, trying to make it easier for independent AIs to find each other and work together.
And beyond those main areas, where else is this starting to matter?
Well, healthcare is a big one.
Mm.
XAI is crucial for building trust in AI diagnostics or predictions.
Understandably so.
Cultural communication, education, maybe AI in virtual worlds explaining cultural context, e-recruitment transparency and ranking algorithms for fairness.
Mm.
Even in our personal lives, AI might eventually interpret subtle cues in our communication to understand us better.
Wow, it really is spreading out. But with all this potential, there've got to be some major challenges too, right?
Oh, absolutely. Plenty of hurdles. On the technical side, for AI to AI stuff, scalability is still a big one. More agents mean more communication overhead, potentially slowing things down.
The bottleneck issue again.
Yep. Security is always paramount. Authentication, encryption, access control, dealing with potentially bad actors.
Malicious AI
So it's
agents.
a possibility you have to guard against. Then we keep hitting that fundamental challenge of semantic interoperability, getting diverse AIs to truly share meaning,
Right.
developing really robust negotiation protocols, ones that can handle different capabilities, failures, misunderstandings gracefully. That's still ongoing work. And of course, that agent communication trilemma is always there, balancing versatility, efficiency, and portability.
Sounds like all those technical problems are kind of tangled together.
They really are. Solving one often affects the others.
Okay. This has been, wow, a really deep dive into meta artificial communication. To kind of pull it all together, what are the absolute key takeaways for listeners?
I think the main message is this. Meta-artificial communication isn't just some fringe academic idea anymore. It's becoming absolutely essential for the future of AI.
Foundational, really.
Exactly. As AI gets more complex, more collaborative, more woven into our lives, the ability for these systems to communicate effectively about their communication with each other and with us is going to be critical for building AI that's robust, reliable, and ultimately trustworthy.
It's about bridging those gaps in understanding and coordination.
Precisely. Across all the different ways AI interacts.
And looking forward, what are the big open questions or hot trends you see shaping this field? Where's the research heading?
Oh, lots of exciting stuff. We'll definitely see more work on robust, flexible meta protocols, more efficient ways for LLMs specifically to communicate, truly interactive, personalized XAI systems. That's a huge area.
Yeah.
Understanding the nuances of trust, both cognitive and affective, in human-AI relationships. The whole debate around standardizing communication versus letting it emerge naturally between agents. Developing smarter dynamic negotiation. Exploring totally new ways for AI to communicate, beyond just language. And crucially, figuring out the governance and ethics around all this powerful communication capability.
So, for people listening who are actually building or deploying AI, what are the key recommendations based on all this? How should they think about meta communication?
I'd say first, design for meta communication right from the start. Don't tack it on later. Second, support and get involved in developing open communication standards that helps everyone. Third, prioritize interactive explainability in any system that interacts with humans.
Make it a dialogue, not a lecture.
Exactly. Fourth, think about effective communication throughout the entire AI development process. Fifth, encourage collaboration between different fields, tech, social science, ethics. And finally, always, always maintain meaningful human oversight and control, especially as these systems get better at communicating.
Fascinating. So here's a final thought to leave everyone with. As AI systems get better and better at talking about talking, what new dynamics are going to emerge between humans and AI and between AIs themselves? And how is that going to change how we even think about intelligence or collaboration?
It's definitely something to ponder.
Absolutely. It's a lot to think about. If you want to dig deeper, definitely check out the research and reports behind this deep dive. Thanks so much for joining us.